Hi everyone, this is Learning with Haneen, and so I received a request to go over fractional exponents, so that's what we're going to do with these couple of questions. So rules to remember just before: if we have a number to an exponent with a root, the exponent is going to become your numerator and your root is going to become your denominator. Same thing with the next example on the bottom. X to the first with the square root of a, and then you're going to have x to the 1 over a. If you have a number that the exponent and the power are the same, it's just going to be the number by itself because they're going to cancel out. They're going to get to an exponent of 1. If you have two numbers under one root, you have to apply the root to both numbers. Same thing if you were dividing them. Now let's get started with some questions. So question 181 says, for all positive values of x, which expression is equivalent to x to the 3/4? So if we apply our rule again, where we had b square root of ac, so what we're going to do, that is going to be equal to a to the c over b. So in this example right here, x to 3/4, the 4 is going to become our root, 3 is going to be our power. So we're going to rewrite it as 4x cubed roots, 4th root x cubed. So that would be answer choice 1. 182. Which expression is an equivalent form of a to the 5th square root of a to the 4th? So this a does not have a root, does not have an exponent, it's just here. So we rewrite this as a times a to the 4/5. Obviously, in order to combine these exponents and add them together, we need common denominators. So we multiply by 5. So we have a to the 5 over 5 times a to the 4 over 5. A equals 9 over 5. Answer choice 2. Number 183 says, the expression, the 4th root of 81 x to the 8th y6 is equivalent to. So you apply to the 4th root to everything. So 81 to the 1/4, x 8 over 4, y 6 over 4. See how I applied the 4th root to each one, even the 81, because the 81 has an imaginary exponent of 1. And then when you simplify this, 81 to the 1/4 is 3 x, so then you have 8 over 4 is just 2, y 6 over 4 is y and 3 over 2, and our answer choice that matches is answer choice 1. Question 185. When b is greater than 0 and d is a positive integer, the expression 3b, the 2 over d is equivalent to. So we write this ourselves. So 3b, 2 over d. Our d, and I just want to point out, we can eliminate answer choice 1 and 3. Why? Because our exponent is not negative. It's not negative. The only time that we do 1 over and then our expression is only when our exponent is negative, and in this case it's not negative. So when we rewrite this, we're going to write it as d root 3b squared. So that's going to align with answer choice number 4. And then question 186. Given x is greater than 0, the expression x 1/5 divided by x 1/2 can be rewritten as, when we divide, we subtract the exponent. So x 1/5 minus x 1/2. We do the common denominator, so that would be 5 over 10 minus x. That's going to be, this is going to be 2 over 10, and then this is going to be 5 over 10. So x to the negative 3/10. We rewrite this as as 1 over, because look, it's negative, x to the 3 over 10, and then we have to match it with one of our answer choices. So we write it as 1 over 10 roots x to the 3rd, matching answer choice number 3. And see how answer choice 2 tries to trick you, but you have to make the exponent represent that negative before changing it to a root. 187, the expression m squared divided by m 1/3 times negative 1/2 is equivalent to. So again, when we divide, we subtract our exponents. So m2 minus m 1/3, so we get 6/3 minus m to the 1/3, which we get m to 5/3. And then we multiply this by 1/2. So m to 5/3 times negative 1/2 equals m to the negative 5/6, and we rewrite as 1 over m to the 5/6. Rewrite it as 1 over 6 roots m to the 5th. Answer choice 2. And so that would be the end of solving radicals using radical exponents and fractional exponents. If you have any questions, please let me know, and thank you for watching today's video. Good luck on your